Good morning. I see everybody has their breakfast, so that's a good thing. On behalf of Convatec, I'd like to welcome you to our breakfast symposium on combating wound chronicity with more than silver technology. I'm Julia Ryan. I am a CWOCM, but I'm also the Associate Director for Clinical Market Development for Convatec. We have a number of folks here from Convatec, so after the presentation, if you have any questions for us, we'd be glad to take them. We're very excited about this presentation. We have one of our scientists here with us. That's always a treat to hear right from the source, kind of how the product was developed, so you're going to hear that. David Parsons has a doctorate in chemistry from the University of Salford, but has developed a wide-ranging interest in physical and material sciences and how these can be applied to the biological world. His PhD researched into water-soluble polymers and their behavior at surfaces, and this is key in many areas of biology, such as blood clotting, biofilm formation, and biocompatibility. He has been with Convatec for over 28 years, working with world-leading experts in skin and wound biology, microbiology, and infection prevention. David holds 10 patents for wound care products, including the formulation and manufacture of AQUACEL Ag and the next generation anti-biofilm, AQUACEL Ag Advantage, which won the Most Innovative Product Award at the most recent World Union of Wound Healing Societies meeting held in 2016. He has authored 26 peer-reviewed papers on hydrofiber, silver, and the performance and safety of wound dressings, and regularly presents at national and international conferences. David is currently Director of Science and Technology at Convatec's Global Development Center in the UK, and is working on new products and technologies for wound, skin, ostomy, and critical care, and the detection and prevention of infection. I'm going to step back a bit because I made a comment just earlier before. The AQUACEL Ag Advantage does not have an FDA indication for biofilm, so I just want to clarify that. We're also very pleased to have with us Dr. Jacqueline Brace. Dr. Brace studied the development of deep tissue injury pressure ulcers for her PhD in wound healing from the University of Virginia. She's an adult nurse practitioner and a board-certified gerontology nurse and WOCM. She currently sees patients in multiple outpatient clinics at the Cleveland Clinic, and patients come from far and wide to see her, and you're going to hear about that. I had the privilege to have Dr. Brace as my WOCM preceptor, and she has been a true mentor to me ever since in wound care. She cares passionately about her patients, and we look forward to her sharing her patient cases with us this morning. Dr. Parsons?
Thank you. It's an absolute delight to be here in Texas. First time I've been, and the welcome's been very warm. My task today is to introduce the product and development of the product, and it's going to be a pleasure looking forward to seeing how well we've done in the US. So let's go back to some basics and just try and think about why we're all here. Now, wounds form. Doesn't matter how they form or the circumstances in which it occurs. If a wound bed is hypoxic, ischemic, and if the patient is compromised with comorbidities, immunosuppressed, is perhaps not looking after themselves, is just suffering from wearing out with old age, we're all wearing out very slowly, then that person is vulnerable for that wound to become chronic. The reality of life is that we're swimming through a soup of microorganisms. That's a good thing. They're essential for our health, they're essential for the health of the world, but they're constantly there. And if these two come together under the right circumstances, then the microorganisms will colonize any surface. And a wound bed is a fabulous opportunity. It's moist, it's full of nutrients, it's an ideal breeding ground. So they're opportunistic, and they will form their own house. And now our understanding is the chances are that this house, this home that they build for themselves, is biofilm. So biofilm is a structured form of bacterial life with any environment. So it's a house in which they live. And we see it all the time. We see this viscous, gooey, coloured substance. It's not unique to wounds. It's sitting there on our teeth nicely. You know, you've all cleaned your teeth nicely this morning, but come mid-afternoon, you're sensing you need to clean them again, and that's because the bacteria are re-establishing, the biofilm is reforming. Now, that biofilm itself is an irritant. It induces a chronic and inflammatory response. And inflammation generates exudate. So biofilm is one of the many reasons that you get exudate in chronic non-healing wounds. And that's got a whole set of problems it causes itself with maceration. A macerated wound edge, like the one we see here in this picture, is a very poor place to start the healing process. And then, of course, being a reservoir of microbes in the wound is quite a dangerous thing. You know, there's always the chance that they will begin to spread and choose or take the opportunity to invade. And that invasion of microorganisms is spreading infection. So whilst biofilm exists in these non-improving wounds, it is always a threat, always a risk. So ask ourselves, what is biofilm? So biofilm is a collection of microbial cells. I use the word microbial because it's more than just bacteria. It could be yeast and fungi as well, and other organisms as well. Typically, it's attached to a surface. We all like to be grounded. It's very hard to be a complete nomad. So they do like to establish a home. So they tend to be adhered. They can adhere to living and non-living tissue. And what they do is they produce their own matrix in which to live. So they excrete this sugary substance. It helps them protect them from outside threats. And it provides a very convenient environment for them. This extracellular polymeric substance, the EPS, the slimy substance, as I say, it's self-expressed, but it is actually a barrier. It's a protecting layer. And any treatment that we provide has got to get through that layer. So it's a defense. And what we find quite often, things that are reported as resistance, is more often than not tolerance. It's the inability of us to deliver the antimicrobial substance to the bacteria because of this defensive system. If we were to remove this defensive system, we'd find the bugs weren't actually resistant at all, that they would be susceptible. So it's tolerance. And then they're associated this with persistent inflammatory response, which we term chronicity, and there's always the risk of infection. So, tell you a little bit about what the biofilm itself is made of. Of course, it's microorganisms and all of their detritus. So anything that they're using or wasting. So it might be proteins, it might be enzymatic substances, proteolytic enzymes that they're producing also generate food sources. And of course, it's all their waste products, which our own body finds toxic. Then there's the polysaccharide itself, the sugary substance that the slime they produce. That's mostly water, but inside this matrix, we often find lots of metal ions, and these have been scavenged from our own exudate. There is other substances, but all of these are important, and I will reflect back on that shortly. And again, on the right, you see a classic example of a laboratory biofilm. Something to bear in mind is we've come to accept that wounds are polymicrobial. Many different species are present, and it's very often impossible and incorrect to attempt to identify one causative organism. It's always a mix, and we find exactly the same in biofilms. Here's a study performed by Jenny Herlo, who's a WOCN working out of Memphis. She got together with Jennifer Gaddy, a laboratory scientist and a microscopist. And together they did a study from the bed to the bench. They got the samples there. She did punch biopsies of this series of wounds. She did, I think it was 16 wounds in total. Did standard histological staining and then popped the samples under the electron micrograph to actually positively identify the bacteria. And on the column on the right, you can see the bacteria themselves. The top picture shows little balls, cocci. The second one down are rods. The third one down is a strange, almost popcorn-like matrix. And at the bottom, there's big balls and small balls. These are different species. So we're seeing different species. There's been other discussions held during the meeting here where people have talked about, can I or can't I see biofilm? Well, I would say at the bottom image, the clinical image, it's very easy to see that biofilm. It's detachable and removed, and when that's sampled, that is clearly bugs. But on the upper image, you may not know. You may think this is slough. You may think this is pus. Yeah, we're not sure. So we can't always see it. It's possible to see it sometimes. But the point is, the components of it are microscopic. So you're never sure if you've got it all. So what does this mean to wound healing? Well, the top statement comes from Dr. Randall Walcott. Randy works out of Lubbock, Texas. He's a clinician and a scientist. And he did a very interesting study. He took microbes from chronic wounds and he implanted them in healthy mice with a surgical wound, and their wounds became chronic. So he made that link. You know, it was the particular microbiome from that human chronic wound that could turn any wound pathogenic and chronic. Other studies, animal studies, the third bullet down talks to Thomas Musto's research group at Northwestern University in Chicago. He's got an ischemic model for biofilm, very reproducible, and he finds that healing is delayed in the presence of biofilm. If he removes it, even in that ischemic wound, normal acute wound healing is restored. And there are papers published about this. And then we have observations about this link between persistent infections and people believing they've identified biofilm. We summarise this all in a nice paper. A colleague of mine, Dan Metcalf, my boss, Phil Bowler, who's a clinical microbiologist, they put this together and they've looked at all the evidence there is, and it's a very nice paper if you'd like to read that. The references at the bottom. But all along, it's linked with these non-responsive and what we call chronic wounds. I talk about chronic just for a brief moment. Chronic is a bad word. Chronic is an acceptance that we're not going to heal it. I think, hopefully, we're going to see some chronic wounds that weren't so chronic after all. That when we address all of the challenges they have, they are actually healable. And I think we owe it to our patients to do the very best for them and not give them this label, you know, unhealable chronic. So, moving out into the clinic, can we see biofilm? Well, sometimes it's quite obvious. It's always indirect signs. There's no definitive clinical test. The only test we've got at the moment is take a punch biopsy, run to the lab very quickly, and if you've got a high-powered electron microscope, you might get lucky. So there's no absolute test available to most clinicians. But you can see it by these indirect signs. Now, if you look at the image A, top left, you'll see perhaps, you might think there's a slimy, sheeny substance there. You might identify that as slough, but it could be an indication of biofilm. If you look to image E, bottom left and top right, which is a dressing removed from a wound, you get a real idea that that's Pseudomonas involved there, and that's definitely slimy. You might be very correct in thinking that were biofilm. And then there's other signs like, can you remove this substance easily? Can you tease it away from the surface? Can you scrape it away without trauma to the patient? And that's normally a sign that that is biofilm. But the point is, whatever you do, this material bounces back. Unless you completely remove it, and that's virtually impossible, because it's microscopic in some elements, you're never certain, it will bounce back and recover. So it's that reoccurrence that is also another great indicator. Here's a table prepared by my colleague, Dan Metcalf, and he compares slough and biofilm side by side. So we've got biofilm, we say it's made of microbial cells, and slough is us, is dead tissue of us, so it's human cells. And then biofilm is alive, slough is mostly dead. Biofilm is this mix of microbial cells, polysaccharides, the sugary substances, proteins, DNA, etc. But slough is cell and proteins. It's made of us. There's the rate of reformation. Slough generates slowly over a period of days. Biofilm can be back within 24 hours. There's a good indicator here in enzymatic debridement. I know that's quite popular in the US. It's a proteolytic enzyme that's used. Now, the only protein present in a structural form is in slough. So whilst these proteolytic enzymes are very effective against removing slough, you'll find that they'll be ineffective against biofilm. So again, that might be a differentiator if you were looking for it. And here is where he gives us his wicked sense of humour. We're saying that biofilm also contains slough, slough also contains biofilm, and that they look sloughy. So we can't tell the difference. So he really helped me out with this slide. So again, let's think about prevalence. What evidence have we got for the occurrence of biofilm in wounds that we label chronic? Well, it's tough because the quality of the studies is not always great. But in 2017, Malone, who's a surgeon working out of Australia, got a team together to do a meta-analysis. So it's an expert panel. They looked at all the data that was available, all the publications, and they graded them and qualified them. And in the end, they only found 9 studies that were worthy of review. And it says here, 185 cases in those studies. And these were studies where it was nicely controlled, that they got punch biopsies and they got to the electron microscope fast enough to be certain. And the scientists then, who looked at them, the microscopists in general found that there were around about 78% of those wounds that were absolutely positive. You've got to remember, scientists are absolute. I know 100% without any doubt is the yes box. So these are 78% of 100% certain. So this is probably an underestimate because they're conservative type. But the point is that the majority of these wounds, the majority of non-progressing wounds are very likely to contain bacteria in this form in the wound. So it's in this background of non-healing wounds with complex microbial colonies, knowing that these are a principal cause of non-progression in wounds, that they're a risk of infection, and they cause this recalcitrance and resistance to antibiotics, not resistance but tolerance of antibiotics, that we needed to do something. We need to do something. So all of that research work was probably done in the period 2003 to 2009. And in 2009, I was given the task, given the explanation by my colleagues in microbiology, biology, biochemistry, and clinical, that this is the challenge. They described to me what it was, and then as a chemist, material scientist, I can take that and start taking it apart. The first choice I made was to stick with silver. Now, an antimicrobial is an antimicrobial if it works. I'm not wedded to silver, but I stuck with silver because it's got a great safety profile. It's got a great long history, so we're good with that. We know it's a very broad spectrum antimicrobial. over the years, we've published many papers on its effectiveness, gram-positive, gram-negative, aerobes, anaerobes, and most multi-drug resistant organisms, or so-called superbugs. We actually invite people to send us bacteria from clinics that people find difficult to clear. But when we get them back into the lab, culture them and challenge them with our dressings, we always find they're susceptible. So we're seeing that as, again, another sign that in the clinic, it's because they're in this more tolerant biofilm form. They're much more difficult to address. The other thing, of course, is we're the company that developed hydrofiber, developed AQUACEL. We know that we need to manage exudate and the moist wound environment, so silver is very compatible with that dressing. And then we talk about the form of silver, or the amount. We know that ionic silver is the active form, that metallic silver must convert to ionic silver in order to work. And there's reasons for that. The reasons for that are that most bacteria have a negative cell wall, negatively charged. Silver is positive, which is great because that means the silver and the bacteria are attracted to each other. That means we can present quite a low concentration, and that the bacteria will collect it and concentrate it up. So they actually create their own lethal environment. The good news is that most mammalian skin cells and cells within the skin structure have no charge. So they only see the general low concentration, which is generally well tolerated. So we've got that slight selection. There's a nice bit of work here that we did in collaboration with Cardiff University Hospital group in 2008, microscopists there, where we're actually dosing bacteria on top of wound dressings, and we're watching them under the electron microscope. And from that, we can get the mode of action. So we see silver being attracted to the cell wall, starting to break down the cell wall, starting to be absorbed through. And when it's absorbed through, if you look at the image on the left, these are healthy Pseudomonas cells, and you've got this granular material within. This is the DNA within the healthy microbial cells. But when silver enters the cell, it coagulates this material, it clumps it together, and that just accelerates cell death and membrane rupture. So it's very, very effective. But it's only effective if it can access the cell wall. And if the cell wall is protected and buried within EPS, then it's ineffective. But you can say that for all antimicrobials and all antibiotics. If they can't reach the target, they're not going to work. So this is one slide representing 3 years of my life. Knowing that we had to address the EPS, the polysaccharide part, the protectin layer, I used my chemical knowledge. I used knowledge gained in the dental industry, in ophthalmics, in food handling, in waste handling, even from oil pipe technology. Oil pipes fur up, crude oil pipes fur up with biofilm. Bugs are tough. They can grow anywhere. Okay. So there's plenty of knowledge out there. I identified the substances, and I knew I need a combination approach, many substances to work together in synergy. So I drew up a list. I got 250,000 experiments that I could do. I selected the best 70,000 and did them over a period of nearly 3 years. So we challenged biofilms with combinations of substances. Following that, I then formulate it into a dressing and then have to take the dressing out and do all the due diligence in laboratory and then in vivo work as well. So, I started this in 2009. This is 10 years of my life now. Okay, so at the end, I found combinations where the activity went through the roof. We had such fabulous synergy. It was terrific. And because you've got that synergy, that means you can edge back on the amount you have to add in. Anything in any great amount is harmful. Okay, so you have too much salt, it hurts you. You have too much water, it hurts you. Okay, you can drink yourself to death with water. So you need to have a safe amount. So because I had this huge activity, I could ease back on the components that I needed to add. So in the end, it's quite small amounts, but the effect is fabulous. And here we can see the components. We label them up as BEC, which is a surfactant, EDTA, which is a biofilm softening, loosening, melting agent, and the Ionic silver himself. And it's working together. They add up to more than just silver, hence the logo. So, a little bit more detail. We stick with the same base product, the same AQUACEL absorbent fibre, performs exactly the same. So dealing with that excess exudate, providing a moist wound healing environment. We stick with 1.2% silver. There's plenty there. We don't run out, and I'll show you proof of that. And we know it's safe. And we add to that a metal chelator. I talked about those metal ions, those calcium, iron, zinc. Well, they're essential for viscosifying, making that polysaccharide thicker. If I can take them away, it becomes looser, softer, and it liquefies. Then I added a surfactant, a very careful choice of surfactant, something that works with the dressing, something that works with silver, something that is very safe. I picked this benzethonium chloride, and that then helps to disperse it and helps to move it into the dressing and help us lock it up. All of these things then expose the bacteria to the lethal effects of silver. So it sounds quite simple. It did take a very long time. Right, let's give you a flavour of how successful we've been. Here's an experiment that the FDA recommended to us. They were quite insistent. They can be quite persuasive. They made us challenge the dressing to the max. Okay, so they insisted that the dressings we tested were at the end of the shelf life. So if they were going off at all, they would be right at the bottom of the curve. They then insisted that we took a simulated exudate and we saturated the dressing in that for the maximum wear time, which is 7 days for most applications in chronic wounds. And then they specified that we had to inoculate these different bacteria. They listed 10 out, which they thought were pretty tough. And what we did then was drop them on to the dressing, and then after a fixed amount of time, the first time point being 6 hours, but then daily afterwards, we would take a dressing, neutralise the silver, and recover the bugs and count them. Okay? So the first time point is 6 hours. And then we compared that with our previous dressing, our AQUACEL AG, without the Advantage more than silver technology. So the new one is in green. So this is the time taken to eradicate the dose they required, which was 10 to the 6, 1 million bacteria per milliliter of inoculum. So here we are with MRSA, USA 300, very standard strain. We eliminated that 10 to the 6 inoculum in under 6 hours, where the original dressing was taken 3 days. VRE, vancomycin-resistant enterococci, same. Staph epidermidis, which is skin bacteria, which is thought to be one of the first colonizers in wounds, again, same, and it goes on. Right down to some of these really tough ones. This is a fungi. This is horrific to kill. We eliminated it, whereas the original dressing did not. So we've got an increase in the speed of action. But we talked about so that was planktonic bacteria inoculated. But we've been talking about bacteria being protected within this sticky matrix. So we needed tests to prove that it was effective there. One of the issues you have is that we stand up here and we talk about what we've done in the laboratory. But all of our thinking is clouded, can be clouded, by the fact that it's our dressing. So we developed the method for our dressing. And of course there's inherent bias in that if we're not careful. So we responded to that. And what we did was we went out to an independent laboratory. Yes, we paid for the research, but we said, please remain independent. Do not let us influence you. Please take this product and measure it in the standard methods that you think fit. And this is one of the ones that they've chosen, and they've used as Centers for Disease Control biofilm reactor model. This again recognised in the US, so it's a US developed model for other diseases that fight biofilm. It's very complex piece of kit. It's a jar, and inside the jar are lots of rods that sit next to a stirrer. But in the rods are placed these little plastic discs. There's 24 of them in total. You assemble the thing in an incubator, you pump a feeding solution in. In the reactor itself, you have the stirrer turning a feed past these rods. You inoculate bacteria, you leave it for 24 hours, and then you pop out those little discs. And the point is those discs are meant to be 24 identical surfaces coated with a biofilm that you then can go on and test your products and compare and contrast. Okay, here's their accreditation. They're accredited by the UK accreditation service, standardised model that is accredited for these two bacteria, staph and Pseudo. Okay, so they're licensed to do this test. They modified it slightly in that they also used Candida albicans, and then they also did a test in which they mixed all bacteria within the same model. Now, it's interesting. Here's a negative control, so no treatment. Here's a positive control where there was no biofilm present. These are bacterial counts on those discs after being treated with dressings for 24 hours and then recovering the bacteria off the disc. But we see a range of our own product and competitor products against this 24-hour-old staph biofilm. They're all effective. We see exactly the same against the Pseudomonas biofilm. They're all effective. However, when we deviate slightly and go for a much tougher biofilm-forming bug like Candida albicans, we start to see differentiation. Only the AQUACEL Ag Advantage was effective. And when we mix species, we see they take on the characteristics of the stronger component in the biofilm. It talks about mixed biofilms. Well, they're collaborative. They use each other. So if one is particularly good at creating the strength of the defensive structure, then it will dominate in that biofilm. And that's exactly what we see in the laboratory. So it's an internationally accepted, standardized model. But our critique of it is it makes pretty thin biofilm. Normally only single species, which are more easy to kill. It's a nice shiny plastic surface. It's very easy to rub this stuff off. But it wasn't until we got a more complex mixture that you start to differentiate. So you'll see lots of people being able to claim that their products are effective at, will be effective if the dressing absorbed biofilm. They will be able to kill it. But then there's detail within the method that you need to look at. Okay, so it's a very simple model. I'll just quickly describe a more complex model, one that we devised in-house that's got a bit more, it starts to reflect a wound a little bit more. It's still in vitro, but it's better. We published this so all can look at that journal. So we start off with a non-adherent gauze. Non-adherent gauze, Na gauze, cellulose gauzes, absolutely perfect substrates for biofilm. They've got a nice rough surface. There's no competition. If you put them in a broth and you shake them gently for 48 hours, you see this lovely gloopy slime start to develop on the gauze. We would then wash that gauze in saline to wash off any stuff that wasn't attached and any planktonic material. And then we place that gauze onto an agar disc in the centre of a plate that's got a suede surface on. The suede surface is our very poor attempt at mimicking skin, but the agar disc itself is providing nutrients and moisture to help that biofilm survive. So we're creating conditions where the biofilm will thrive. We then pop our test dressing on. We add a simulated exudate with all those things that are going to compete, and then we pop on a top dressing and incubate at body temperature. We create hundreds of these at a time. That's so after a fixed length of time, we can come along, pull the dressing off, we could put more bacteria on as if it had been more recontaminated, or we can take the gauze off, we can neutralise any silver, and we can then use chemical means to release the bacteria and count them normally. But we can take those biofilms away, those biofilm discs away, and look at them. And here's one thing we do. One of the first things we do is we pop them back under the microscope. We're lucky enough to have a confocal laser scanning microscope, which is good at seeing through jelly-like substances. We can use histological stains to stain the bacteria, and here we're using live dead stain. The green stain stains the cells, live cells, and when they die, they lose the green and show up as red. So it's green is live, red is dead. Easy as that. It can look in 3 dimensions as well and reconstruct that in the computer, so you see a cube to show it's got thickness as well as dimensions of length and width. You can see this is the original biofilm, so it's thick, it's got a fluffy surface, and it's mostly alive. And here we see various dressings after a 24-hour placement. We pick on these particular dressings because these are higher in silver than our own products. And this really goes to prove that it's not about the silver content, it's about how it's made available to the target. It's removing the barrier and making the silver more effective. So with the particular dressing here, ActiCoat, we see lots of dead cells, which is good, but we see survival. Any survival will lead to regrowth. And we see silver here, cells here, which has been perhaps less effective at removing that. With our own dressing, we see that many, many fewer cells, so much of it has gone, been dispersed, and anything residing still on the gauze is mostly dead. That's not completely dead, that will need another treatment, but it's well on the way. Again, these things are published. This particular biofilm's a mix of Staph and Klebsiella. Klebsiella is a real slimy bacteria, so this is quite a tough biofilm. We can also take those gauzes and count the bacteria, as we would normally. Product and the control against MRSA, and this is a extended spectrum beta-lactamase excreting Pseudomonas aeruginosa, a multi-drug resistant organism as well. And we see the difference in effectiveness. You know, the ability, MRSA, MRSA is a tough one to crack. It makes tough biofilm. It takes us here 5 days to clear it. When we put bacteria back in, lo and behold, the dressing keeps going. So there's more than enough silver, there's more than enough power. And we see the differentiation. People often use Pseudomonas because Pseudomonas is particularly sensitive to silver. So that's not a great example to be using to promote the effectiveness of your own dressing. We repeated this against a few competitor fibre dressings, and again, it's clearly differentiated. The one with the more than silver technology, AQUACEL Ag Advantage, is just much more effective. One thing to note is before by the FDA, we were asked to challenge with 1 million bacteria per milliliter. When we come to real biofilms that we've grown, we actually find that the populations are so much greater than that challenge that we were asked to do. We're up here at 10 billion times. This is 10,000-fold greater than the FDA had originally asked us to look at. in that planktonic test. So, nearly finished. We'll get to the exciting part, which is the clinical evidence. We've got a combination of substances that work together. They work together, so if we can get the biofilm into the dressing, in close proximity to the dressing, we can start reducing its viscosity, we can start cleaning up, we can get it absorbed into the dressing and killed. It's a unique combination. It's taken probably upwards of 10 years to get there. It uses Ionic silver, which we know is safe and broad spectrum. It uses small amounts of this chelating agent that helps break down that biofilm slime, and a cleansing agent that helps lift it into the dressing, benzethonium chloride. And the results are spectacular. Don't take this presentation as proof of that. Go and seek out the literature. We've got 28 peer-reviewed publications to date on our research into biofilm and how to address it, and the evidence we have that our product is going to be effective if biofilm were to be absorbed into the dressing. I keep saying that because that's our license with the FDA, absorbed within the dressing. So with that, it's a great pleasure to hand over to Jacqueline to find out how well it's worked. I haven't seen these slides yet, so I hope it's good.
I hope so too.
Thank you.
Alrighty. So, in working with Julia, her as a student, I must say, she was the most incredible student I ever had. She made me go back to the research and question why I did what I did. So, she's just absolutely brilliant, and having the pleasure of now being a friend. So, thank you. So, AQUACEL Advantage, I'm one of the ones that say, okay, show me the evidence. So, Julia says, okay, try it. So I have some case studies for you, and with permission of all my patients, they were actually, if they didn't have an appointment, they were sending me pictures on my cell phone to keep me updated every week. This first patient, love her to death. She's a 71-year-old who had a vascular spinal cord infarct. She woke up one morning, couldn't move her legs, reached for her cell phone, called her daughter, who is an ICU neuro nurse. And her daughter went running over and called 911. So with her history, though, she's had a AAA repair, she's had carotid stenosis, she has hypertension, CAD. That was basically it for her, but it's all vascular. She's not a diabetic. She ate very well. She was very active. She was going out to, they have this really cool wellness center out by where she lives, and she was actually swimming that week up until the time she became a paraplegic, is what she's calling herself now. So when she came to me, she had bilateral heel ulcers. The one on the right side actually had healed. It was still a little bit scabbed over, but her left heel, 100% soft necrotic tissue. It was demarcated. So the first thing, of course, we do is wash it real good.
You need to move it on.
Oh, no, yeah.
Okay.
This is still the history. So with the necrotic tissue, I debrided the outer layer, and I took the tissue from within, and I sent that off to the lab, and she grew MRSA. Also, we did an x-ray to make sure that there was no infection in the bone. Luckily, there was no infection of the bone. So I did my normal standard treatment. We did Santal to the wound. I treated the MRSA with PO, doxycycline. So back in December, this is when Julie and I had our discussion, and I said, well, yeah, let me switch this treatment over and see how the AQUACEL AG works. So right in here is where the actual wound actually penetrated down to the bone, and it extended all the way out. Right here was a tunneling up the plantar surface of her foot. So in all patients, I just ask them, please wash, soap and water. My thing is Bounty paper towel, the quicker picker-upper. Dry your wounds, pat dry your wounds. That way they're not using their towels and running their towels through the washing machine and then drying them. So they actually use soap and water, and they wash their wounds, and then pat it dry with the Bounty paper towel and throw it away. A lot of the products that our DME companies send, their gauze falls apart, and I'm finding gauze fibers within the wound. Ever since we switched to the Bounty paper towels, I don't see any fibers in the wound bases anymore. So back, she came in, and on 11/21, I was just totally amazed. I said, okay. So into this area, that pro bone, we were just cutting a piece of the AQUACEL Ag Advantage and laying it gently in, not overpacking it, just loosely packing it into the wound and then covering the rest. And I asked the daughter to go past the wound edge just to keep that area dry, because if there was drainage. Now, luckily, she didn't have any edema. She was able to offload, and just super care from her daughter. No home care nurses, because her daughter goes, I can take care of this myself, and feeds her very well. She eats steak every other day because that's what she likes to eat. So that was very, very helpful. So in February 4th, this was again incredible. She had, in January, I didn't see her. She was in the hospital because she did come down with the flu. And then when she came home, her daughter started up the treatment again. She tried having the hospital use what she was using at home, and the hospital said it wasn't on formulary. They refused to stick to the treatment. So on February 4th, she started the treatment again. You can see the dryness on the outside. And I had asked the daughter to add a little bit of A&D ointment or Eucerin lotion, something to hydrate that, so when she washes it, it would peel right off and come off. But you can notice that quickly, the area that probed the bone filled in beautifully. Nice, healthy granulation tissue in the center. When we have all this dry tissue around it, I always ask them to hydrate, because as wounds fill in, we need them to close over. And if they have the dry exudate on the outside or the dry tissue, we're not going to have that scar tissue complete as quick as we need to. So this was on 2/25. She had a little bit of a bump with her wheelchair and the footrest. So I was a little concerned about that purple area right there, but you can see how that's all filling in really nicely. On March 11th, we still have a little bit of that area, but everything, again, is closing in. I said, how do you think that bump happened with the wheelchair? She goes, you know, I got my toenails done. She went and had a mani-pedi, and the girl that was doing forgot that she was a para and just dropped her foot down. And that's how she now remembered telling the story at this point. So watching it again closely with that. And then on 4/1. So this was a stage 4. It had been infected. And during the period of March, she came in, her urine was cloudy. She had a horrific odor coming from her Foley bag. So I grabbed a culture of her urine, and she had MRSA, because we changed her Foley and did as clean of a catch urine that we can. And she had MRSA again with that. And we treated her with some, I think that one we did Bactrim. And she is doing great. She still sends me pictures, and the last picture I got was her sitting there with a big steak in front of her and baked potato, and her fork and knife like this with a big smile. So it's just really, again, just incredible with the quickness, the healing rate that I saw. So I said, okay, all the other patients are sending me pictures. So my next guy, he is a 57-year-old that is a nurse, and his wife is a nurse. He has diabetes, CAD, he has chronic kidney disease at this stage, hypertension, he's had a heart attack, but he had fallen and he had broken his knee so bad that they had to put hardware in. Next thing you know, he has a swollen knee, it's hot, it's red, it's painful. They take him in, the hardware was infected. So they took the hardware out, put a spacer in, everything was going well. Okay, we'll switch you back. They did another surgery, and it just keeps going on. He's had 5 surgeries to his right knee. So his leg brace is all the way from his thigh all the way down to his heel, and he's only allowed a 5 or a 10-degree bend of the knee. He's not allowed to shower to take that brace off because they're afraid of the knee and the instability of it. So he washes just his leg in bed, and then he'll cover that up with a plastic bag to shower the rest of him. The foot part of the leg brace was the cause of this pressure ulcer. So we sent him out to the people that made it, the prosthetic company, and they did do an adjustment, but it wasn't quite enough. So I was able to find a gel pad and put that inside the footrest piece of it. We can use any product to heal wounds, but we've got to take care of the etiology. We can use the best product in the world, but if we don't offload, if we don't give them blood flow, it's going to cause us some problems. So again, looking at your patient from head to toe, medically and physically, to give them the best opportunity to heal these wounds. So he has a right heel pressure ulcer, stage 4, and he has a knee wound infection. So what they had to do is they went in, took him in, did another washout, put another spacer in. So I'm like, okay, what are we going to do? But while he was in there with ortho, actually did a debridement in the operating room and took a tissue sample. He also grew a staph. So he was growing staph and Pseudomonas in his knee, and he was growing staph in his wound. So luckily we had a PICC line, we did IV antibiotics because we're dealing with the ortho and the bone piece of it. So that really, really helped us heal. But locally, it was very wet because of all the edema from just the recent surgery. And if I put an A-strap on his leg or a compression, he was just in too much pain. So all I can do was a tubie grip. And he loved it because the first day the tubie grip was too tight, so we couldn't wait for it to kind of stretch out a little bit, and then it felt good. But it wasn't really helping us with the edema. So he had a lot of drainage because of the edema of his leg. So on March 21st, this is when we started the AQUACEL Ag Advantage. And this was on March 31st. Just amazing. Change. And that's the only thing we did was change the treatment to the AQUACEL AG. This was on April 21st. And again, I'm going to flip between the two. This is just so impressive. Again, nothing is done. We still have the brace. We still have the pressure. We have the offloading of the brace. He still has the edema of his leg because of the surgery, and we can't do a good compression on him because of the pain. And then to April 21st, an impressive, and he's not showering. He's just bathing on, in bed, or his wife is actually bathing his leg. And here was April 15th. Just again, a little bit of dryness around this area because there's no more drainage from the wound. So I asked his wife to put a little hydration there. Again, a Eucerin cream, lotion, or A&D ointment. And just lay the AQUACEL AG inside the wound, not over the wound. So she was cutting it and placing it right inside. So this is April 30th, and just two little areas of the wound that was left open. And I just sitting here now, just got a text from his wife that he's completely healed and they just canceled the appointment for Monday. So the timing is incredible. He still has a lot of medical issues going on, but he healed very, very nicely. My next lady, she's a character, I'd say. She has COPD, cirrhosis of the liver, but tells me I don't have cirrhosis. She has CHF, but she doesn't have a heart condition, she's telling me. Hypertension and depression, sleep apnea. She is one that she's not drinking anymore, but she came in, her face was bruised. She has sutures all over her face. Her ear was kind of ripped off, so they glued it in place because it was St. Patty's Day last year, and she had a little bit too much to drink and fell off the bar stool. What she didn't realize is that's a very common place for the nurses in that area to go, and the nurses saw and went and helped her. But she doesn't drink anymore. So we have a lot of medical issues with her kidneys, her liver, her respiratory status. Who's your pulmonologist? I don't have one. Well, who's ordering your oxygen? I don't know. They keep giving me the tanks. What should you be on? Well, today I felt using 5. I was a little short of breath. So she does her own stuff. She told me that her primary care doctor fired her. I said, no, 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 your primary care doctor just retired. Oh, no, he fired me. That's the letter I got. So we have a little bit of an issue here with compliance, if you will. So her bilateral, sorry, I'm just getting used to the clicker here. I meant to go like this. So her bilateral venous ulcers were present since 2012. She came to me on 2017. These ulcers were very pale, that punched out. The right side was pretty much the lateral and the medial aspect. And I'm thinking, okay, what treatment are you doing? Well, I tried this. What else did you? Oh, I tried that. How many wound centers have you been to? I've been to 4, but they keep saying go find someone else. I'm like, okay. So, but I feel for her because she's so frustrated with the wounds and what to do with these. So we were doing local care. We treated her infection. I was able to do wraps. She didn't like the wraps one day. She took a steak knife and decided to cut them off her leg. So a lot of problems, but the wounds were looking great. We had then skin grafts placed. They were doing great, and I happened to go to that nursing home to follow her there because she went to one of the homes that I went to. And I walked in and I see her picking. She's picking her donor site, creating a wound. Then I saw, because she's in a hospital gown, her upper back, her chest. Here, she self-mutilates and picks. Now it tied everything together why her lower extremities were not healing, because she is a picker. I'm a picker. My nurse is a grinner, but I'm picking because I'm debriding, okay? Not because I'm just picking to pick for the fun of it. So she's had multiple hospitalizations for cellulitis and wound infections. So in March 27th, I'm like, okay, this is the 3rd time that she had MRSA. Right before her surgery, we did a culture. There was no bacteria. Everything was going good. When she went to the nursing home, she started draining after the picking, and in the nursing home, she was positive for MRSA. So what we did was we did the HIPAA cleanse for 6 weeks. Lower extremity HIPAA cleanse, 6 weeks, antibiotics for 6 weeks, and local care. As soon as we stopped, cellulitis, back in the hospital. So it's just a vicious cycle. So when she came in on March 27th, I said, let's try AQUACEL Ag, see how we do. She has the necrotic tissue right in here. That is not biofilm. That is definitely necrotic tissue, because I tried to scrape it off. I'll use a curette. I use anything sharp to remove biofilm in the office. And it wouldn't come off, so I'm like, okay, so that, we looked over on her right leg. This is her medial aspect. Her wound was all the way out to here, so some of her skin graft did take and did heal. So I have these scattered areas right here. She did the pictures on the 27th of her right leg, and then she did a picture on the 29th. Sorry, that should be the 29th. I didn't realize I had a typo there. And then she sent me on the medial, the lateral aspect of her right leg. Lots of drainage, but we did vascular studies. She doesn't have anything that would cause all of this drainage coming. She has one little tiny perforator that won't affect the amount of drainage she has. Once we started the just ACE wrap compression, the edema was under control. So we get moderate to small to moderate amount every day. So therefore we have to change her dressings every day, or we have the strike through drainage for her. This is April 6th. You can see how healthy the wound bed is. This is the healthiest I've seen her in a very long time. She has healthier scar tissue. The base is cleaning up. And you can see over here, she has some scar tissue. I call them little islands coming through her wound bed, right in here. And now I see a different change with her. She is very excited. She sees the change. The biggest thing, too, that we haven't talked about is pain. In the beginning, when I started taking care of her, I couldn't touch her. I had to use lidocaine gel to numb her just to even get a measurement for her. I wasn't quite sure what was going on, but with the infection, yeah, This is the first time that I can actually say I take the cleaner and I wash her leg and do the measurements to do the dressing. And even if I have to pick something or clean a little film out in one area, she has no pain at all, which is pretty impressive also. And here's her right lateral, and she has brand new scar tissue in the center of her wound. And this is on the 29th. Filled in, much smaller. For her, she's like, it's not a big change, but for her, the 0.5 centimeter, the 1 centimeter, change in the width, change in length, but especially the depth. This is now 0.3 depth, which is pretty impressive, and it's good granulation tissue coming through. And when I take the dressing off, there is no biofilm in her wound bed at all. So now she has home care that comes out, but she doesn't let home care do it. They have to watch her so she can show them how to do it. I love it. She's finally taken ownership of her wound, which is incredible. And this here, just filling in, healthy scar tissue coming all throughout. And her worst wound on the right lateral, looking great. It took a long time for her to trust, for her to accept what she should be doing. She now sees GI for her liver cirrhosis. She has regular appointments with cardiology, pulmonology. She is coming in just so happy. Her hair's done. She's now dressing, and she's on a dating website now. So she's all excited. She feels like she has started to change her life around, which, again, giving the patient that ownership of their wound, of their care, and their families, you just get so much more excitement and joy when they come into the office and say, okay, what are we doing now? So it's just, again, an incredible thing to see patients heal this well. So this gentleman, he's a kind of funny guy. When he taught, he just retired, he would sit at his desk and teach all day long. So he was 407 pounds when I met him back in 2007. Kept talking about weight loss, weight loss, weight loss. He's down 54 pounds, which is I'm just so happy for him. But he's a diabetic. He's on AFib. He has AFib, so he's on Ticocin. Now, anyone that has worked with some of these newer drugs, there's a lot of interaction with the antibiotics. So I can't run even Cipro or Bactrim for him because of the interaction with his heart. It could cause life-changing event for him. He has spinal stenosis, the lymphedema, and he's had this venous ulcer present since 2006. He's had many different wound doctors, many different places to go, but he has lymphedema. He didn't have compression pumps. I said, what kind of stockings do you wear? My diabetic socks. I said, what kind of compression? Well, what are you talking about? His wife was there, and so educating them both, I got them compression pumps for both legs. One of the companies out there was only given one sleeve to see if they're compliant. You can't do that. I need 2 sleeves. So he has pumps that go, and I had him measure for custom, so they're really high thigh compression sleeves for him. We did a study, and we actually found that he had the doctor says this thing is a tube. He had such a distended vein from his thigh all the way down, and he had perforators all over the place feeding this ulcer. So when he went in, he took care of the upper thigh, and then we fixed the issue that was causing the venous congestion down by his gaiter area on his leg. Then he did have a split thickness skin graft in 2018. So, excuse me, he was being treated, local care. The wound looks absolutely wonderful. So this is one of my guys that comes from out of state. He comes from, I have 3 patients that you're going to see, these 3. He's the first one in one of the out of state Ohio patients. So the wound looked absolutely wonderful. We're getting the edema under control. And I sent him for, because I figured he is compliant. He had at this point lost 25 pounds, so it's time to start talking skin graft. So the doctor just said, okay, because I said, do you want it here or do you want it at home? I'll get it at home, send all the information over. So this is March 5th. He had a little bit of an issue. Don't know why he had that yellow tissue. This is slough. It was not biofilm. It wasn't removable. So he did then, because he sent me that picture, he sends me this picture on 3/16. He had the skin graft. But what's under the skin graft? Slough. Was that appropriate to do a skin graft? No, I didn't think so either. So it was one of those things, okay, let's see how we can protect your leg. But because the doctor did the skin graft in a different state, he stayed in the other state at their wound center to follow the surgical wound. So he comes back to me in June. The skin graft has some took, some didn't take, but he's all red and he's moist in that area. What's your treatment? They put Zeroform, ABD, and an ACE wrap. I'm like, okay, sir, but you're allergic to shellfish and contrast dye, iodine. So they have him doing a Zeroform, but he's allergic to iodine. This was all allergic reaction to this area here. So he went back and they did change the treatment. And he did eventually, he had 1 or 2 little spots and it looked great. I get a phone call from him and he said, I was itchy. I said, what do you mean you're itchy? So he had his compression on and he just dug. I said, what did you dig with? Well, my ruler. I was sitting there and I just kept rubbing. That was my ruler. And he started having some swelling, some drainage. So we recultured him. Meanwhile, I'm like, okay, what can we do? He's on Ticacin. He now has Pseudomonas and staph. I really need to give him some Bactrim and some Cipro. So I called his cardiologist, had a discussion with him, had a discussion with his PCP. What can we do to get him to heal? I really need to run these antibiotics. Because in fact, when he did go to infectious disease, they would only put him on Keflex because they didn't want to touch the Ticacin. We need to treat this guy's infection. So with permission with his cardiologist, PCP, close monitoring, we took him off the Ticacin and we ran the antibiotics. And he did fairly well, but at this point, this is when I started the AQUACEL AG for him because he was in there digging. But I also sent him to dermatology because there was a couple weird lesions that popped up on his upper thigh. They looked kind of psoriasis. So he went to dermatology and had them biopsied. So just from February 8th to March 18th, his leg has dried up, it's cleaned up. He did have a little bit of biofilm there that I just took a curette and took the biofilm out. But this is a newer lesion down here, and I sent him to dermatology for a biopsy of that also. Now, poor guy, his surgical pathology came back that he is having a drug reaction to allopurinol for his gout. So now we're into another problem. So it's like we fix one, and now we're hitting another. But he keeps losing the weight down to 54 pounds. So here he was on April 21st. This here, we did the biopsy here, and this is it. This is just the bottom part. And I think part of it could be the way he's compressing. So we actually ordered him measured him now for compression stocking so it wasn't cutting in down there. So this gentleman here, he's lymphedema, diabetic, hypertension, obesity, had a right knee replacement also. He had the infection of the hardware with staph, and he's had this on and off for 17 years. This is how he presented to me. I said, okay, sir, what are you doing for your wound? Well, I have no money. My wife changed jobs, and this is a pre-existing diagnosis, that and his diabetes, he has to buy his own wound care supplies. He doesn't have the money, so he's using his wife's sanitary napkins, he said, yep, to suck out the drainage. I said, how about a compression pump? It's been broken. The insurance company wouldn't fix it because it was, you know, he wouldn't replace it because it was pre-existing condition also. So took cultures, started compression. I got him a pro bono pump until we got the insurance to approve it, and he started compressing. Just an incredible change with AQUACEL AG. And then here he's filling up, he's doing great, and he's doing his own dressing changes. He's from out of town, he's sending me pictures. He still has some biofilm. He was afraid to wash his wound deep enough. But I asked him, what's going on? You're having this yellow biofilm and increased drainage. Well, you know, because he's a farmer, he says, we're having some strange odor coming from our water when I'm showering. He had gotten a bacteria in his well, and the bacteria from the well water was getting into his wound. He's a dairy farmer, needless to say anymore. Okay, so he got his well redone, clean water system, all of that, because he was bathing in basically dirty water. And then here, just incredible healing on this guy. This is all brand new scar tissue, no skin graft, just compression and AQUACEL AG, and treated the infection to begin with. Closing down nicely. And this is February and March. So just he sees the outcome. We fix his water issue, his compression issue, and the infection. Excuse me again. So this lady comes from another state with anemia, obesity, PVD. She also had DVTs after she had a child. So her venous leg presented since 2006 also. So she came into the office in July of last year. This here is a dressing underneath. I can't get the dressing off. She was told, put this as a base layer. The only thing you need to do is change the pads on the outside and then change the other dressing, which is material. It wasn't something that would dissolve. And you could see the necrotic tissue all along, the edema of her foot because she wasn't compressing, because she was in so much pain. She couldn't use the pumps and she couldn't wrap. 42-year-old, okay? Just breaks your heart. So here's another angle. You can see I can't even get in there to clean her, so we sent her into the OR for a washout and removal of that material, the dressing that was underneath. I'm not going to tell you the name of that dressing, but just don't use it. No, I'm joking. Just have them change it more frequently than every 2 weeks because this got embedded and got infected. She's been growing a strep C. Strep C is the same bacteria that causes necrotizing fasciitis. In addition to MRSA, in addition to E. coli, in addition to Pseudomonas. She's got 4 bacteria going on that I took in my office that they confirmed in the OR. But she wanted to leave the next day and left against medical advice because she had her kids to go home to take care of. She went and wait for her PICC line and then calls me crying that her wound's infected again. So here's another picture. And let me just say, this is after the operation, okay? The necrotic tissue came back. So here she had been, after the surgeon had wanted her to go to a wound center near her, and they started throwing some hydroferrin blue in there and just an ABD pad. She wasn't putting a treatment on there. I said, why? She says, I'm not sure what they wanted me to do. Did you call them? No. So again, a lot of education, a lot of hands-on education for the patients. So on the 10th, we basically, I said, come on in, come back, and this is her when she came in. So she saw some blue, so that tells me she's not washing her skin or washing the wound, correct? Because the hydroferrin blue is still on her skin. And necrotic tissue again. So what I did was, in January, okay, AQUACEL Ag Advantage, let's give this a try. So she started doing some compression. Her edema's going down. We had IV antibiotics going from ID because I said you need a pick, and she agreed. So now she's getting a little bit more compliant because of the pain. But look at the change from the 9th, when we started the AQUACEL Ag Advantage, to January 16th. This, I think, is just incredible. This is all because of the dry tissue. I have her putting some eucerin cream on that. I told her to rub it in. She globbed it on, and then, of course, it caked up a little bit. But just, again, incredible change in this wound from the 9th to the 16th. What I watch for now is all this new scar tissue that is under the cream here. The base is filling up, less pain. Now she's using her compression wraps. I still can't get her to be compliant with the pumps. I gotta live, you know, is what she says to me. But even though she's not compressing tight enough, she's not using a compression pump, she's not elevating because of her job, she is still showing signs of healing. She has too much edema to really look at the vessels to see where the perforators are, what's causing some of this congestion down there, and to see if anything's fixed. So once I get more of the edema out, I'll repeat the venous studies to see if we can fix some of the veins. All the scar tissue right in here, just incredible. And you can see from here up is all new scar tissue with little areas. We still have that necrotic tissue in there. So I have her doing a little bit of Santal to that because it's thick, but I can't debride her in the office. She's in too much pain. So I have a little bit of Santal to that, and then everything else is the AQUACEL AG. More scar tissue here, more scar tissue coming down. And this is her taking pictures straight down on her leg. This is all brand new for her. And it's taking a very long time until we started with the AQUACEL AG. All this growth is new since the end of January. And that's it. Thank you very much.
Thank you very much, Dr. Parsons, Dr. Brace. I know we're short on time, but we will take a few questions if there are any.
That's great.
Thank you.
Hold on a second. I'm going to come here with the mic.
Got the science behind it now. Yay. I think
Question for the doctor. Did you say that you use Santal and you use the AQUACEL AG? Is that okay now? AG doesn't deactivate the Santal?
Do you want me to take that one?
Yeah.
They're not compatible. The silver will deactivate the enzyme in Santal, so you can't use them simultaneously, but you can use them sequentially. So as long as you've treated with Santal and removed it, then you can dress.
I actually had her do the Santal on that side, and then she just used a regular hydrofiber there, and then the rest was the AG. So I should have said that. Thank you very much.
Can I just add something? Because actually there's minimal deactivation. There's minimal deactivation of the Santal because of the latest studies they've done. As long as it's under 20% inhibition, you can use them simultaneously. So there's a whole list now if you go to the Santal.com website.
Okay, that's their recommendation.
Yes.
Our recommendation is it will reduce the effectiveness of the silver as well. So and their recommendation is that, and ours is take care.
Do you, sometimes with a wound that's too dry and you still want to use that product, do you ever pre-moisten it?
Well, now that I just started the AG, I haven't had it, or the Advantage, I haven't had anyone that had to wet it, but when I use the AQUACEL AG, yes, to trigger and activate it. With the home care, it's very difficult. Okay, so 1 week we're going to do this, and it's wet. Next week it's drier. To keep switching products back and forth, so I will tell them, okay, at this point, keep the same treatment, add a little bit of normal saline to the dressing just to trigger it, to keep it moist. Correct. I'm always thinking about cost also for the home care patients.
Any additional questions?
Do we have any more data, animal study data? You show a lot of in vitro, and then you show the case study. Do you have any tests in the animals?
Yes, we do, and Dr. Musto's group has published that animal experimentation. So that is available in the international press. In that list of 28 peer-reviewed publications, they're there. It's in vitro, in vivo, and clinical. But our plans are to publish more specifically in the US with US best practice.
Okay, well, if there aren't any more questions, thank you guys again, and thank you for joining us this morning.
Thank you.
Thank you.
Yep.